Morning, one and all. Can you able to see the screen?
Yes, ma'am. Yes, ma'am. We're able to hear you.
The screen is visible to all. PPT screen.
Yes, ma'am.
In the previous class, we started with module 2.
Yes, ma'am.
Most of you submitted the assignment, and I shared with you the important I think I shared with you the assignment questions. I will share you some important questions also.
Okay.
Yeah, our module is software design and UML use case modeling. In the previous class, we discussed the introduction to UML and UML diagrams, and the best practices, dynamic and static diagrams, the to design a project or a project proposal. So in the previous class itself, we started with the basic concepts of process design. In module 2, we have the following topics like process of design, principles leading to good design, techniques for making good design decisions, and good design document. I think up to that we discussed. I think the remaining topics, design patterns, software architecture, architectural patterns, and types are still pending.
Yes, sir.
So in the process of design, we discussed what is design and how the design should be made, what are the principles and the important parameters we need to consider while going for the design model of your proposed work, research work. And in a designer's, what are the issues they may face during the design phase and how to solve, and what are the aspects we need to consider. I think that we discussed this in the previous class. Then what is the process of design? What are the steps involved? What are the systematic stages we need to follow? Then making good decisions. So while making a research proposal or objective, what are the decisions you need to consider while making the objectives? Say, know the requirements, know knowledge of the design as created so far, and knowledge of the technology available. What are the technologies, latest techniques available, and the knowledge of software design principles and the best practices. So what are the design principles available or methodologies, methods available, and what are the best practices followed in each methodology, and how it is suitable to the taken framework or the proposed model, and knowledge about what has worked well in the past. Which particular model or methodology is giving you the maximum or optimal solution in the last or the recent research. And we saw what is the design phase. So we know very well we cannot do the research or we cannot do anything for the whole world. We need to fix our framework or we need to fix our boundary. So within the given within the boundary for the given customers or the end users or stakeholders, with subject to the conditions and constraints, we need to frame our research work. So the design space should be well-defined one, and within the boundary or within the defined research space, we need to take the best methods, algorithms, technologies, and the efficient concepts available, and who will be the end user, and for them what, in which way we can give the effective result. Then we saw the differences between component, module, and system. So we know very well system is the full complete design space, and within the system we will have a number of modules. Each module may contain a number of components. So the components means it deals with software as well as hardware parts, and module contains the various functional modules of your project, the software or logical components, and the system as a whole, it includes both software as well as hardware, and it defines the in the deployment in which area, who are all the users, what are the elements, hardware and software components we are providing to run the project. Systems, how the subsystems can be defined and represented using UML diagrams. So subsystems can be easily represented by using inheritance. We'll have the base class, and from the base classes we can create the derived classes. while representing the base class and derived class, we will use the composition aggregation as well as the easier relationship or part of relationship among various subsystems or the logical components. So here they are taking the system. So it is an object because it's having only two rows, object name and the attributes. So this particular, it is, there will be n number of systems, and in each system there may be one or multiple number of components. So it is the same way from the system we can create a number of subsystems, the aggregation of all the subsystems. So this aggregation symbol is used, it gives the complete system. And the subsystem is derived from the base class system. Here in the component, we have modules as well as frameworks. Both modules and frameworks together, the aggregation will give us the component. So here this particular subsystem diagram using object diagram represents how we can make use of the UML diagrams to represent the system and subsystem. Then we discussed the top-down approach and bottom-up approach. So in top-down approach, mostly it's used in the structured programming languages like Fortran, COBOL, C. So we need to declare and define everything before using the components or functions in the main program. So that is the top-down approach. So first design the very high-level structure of the system, then gradually work down to detailed decisions about low-level constructs. Finally, arrive at detailed decisions such as the format or particular data items, individual algorithms, and other functions. So the same way we can make use of top-down approach or bottom-up approach in the project research space. If it is top-down, we'll go from say the various algorithms, methods, methodologies, proposed model. Then we'll go for the implementation. Then we'll try to implement, produce the results, and we'll show the contribution and justify what we found is the efficient result and it is not already existing. So that is the top-down approach. Or if you take bottom-up approach, we'll already go through the literature review. From the literature review, we'll come to know what is existing, what is lagging in the existing research works. So by identifying the research gap or by identifying the issues which are published in the current research trend, I will say the existing research produces only 75% of result, and we can fix our target as 85 or 90. And what are the methods and methodologies they used? So they may be using low-end technology or less efficient algorithms and methods and methodologies. So we can go for high configuration with latest advancements. Then accordingly, from result to the previous steps. So we'll fix the contribution, we'll fix the target, we'll fix the efficiency, what we are going to justify. From there, we will proceed further. So contributing results to methodology, from methodology to methods, from methods to the diagrams proposed model, from proposed model to we will fix the objectives, and from the objectives we will go for the corresponding literature review papers. So we'll choose the latest publications which are having less than what we are going to prove or justify, and those who are using lesser configuration side, the technology algorithms may be on the not the latest one. So we may take the published research works of 1 or 2 years before. They may used they may not use to the perfect algorithm. They may not use to the languages and other technologies. So then we will fix the, based on the objectives, we will fix the introduction part, literature review, as well as introduction and abstract. So we'll proceed from results to objectives, or objectives to results and contributions and findings. So the same way, the same thing we are following in top-down approach as well as in the bottom-up approach. It's used in many of the programming languages, as well as it's used in the algorithmic side, as well as it is used in the object-oriented analysis and design, as well as in the unified modeling concepts. Then we discussed the different types of software design methods. So what are the different typically used software design techniques means? We have the architectural designs, class designs, user interface design, database design, algorithmic design, and protocol design. If you take any research work, we have our own core idea, core implementation, methodology, methods, and results. So that alone we cannot, that is not enough. That will give you only the 50% of your research work. So you need to concentrate on the architectural design part, the class and object design and other use case model designs, user interface design, database design, backend tools, algorithmic design, protocol design. All those parameters we need to consider as part of our research work. Then only the introduction part, chapter 1, literature review, related works. That's chapter 2, proposed work, methods, use case diagrams. Again, the chapter 3 will be your actual methodology, results, implementations, all those things. Again, chapter 5 will be conclusion and other references, updates, all those things. So your actual work will be represented in the module 4. The remaining module 1, 2, 3 as well as module 5 is based on these parameters. Then only if you concentrate on these aspects also, chapter 1, 2, 3 as well as chapter 5, then only you will get the complete research work or thesis report. So you are showing some result, you are producing some efficiency, and you are showing a novel method. All those things in the chapter 4. That alone will not be accepted as a research work. Or so you have to go for the corresponding. What are the architectural models you are showing? So pictorially you can represent what you are. The architectural design will show you what are the components you are using, what are the methods you are using, what kind of representation, network model or object-oriented model or prototype model you are using, what is your front end, what is your back end, how you are connecting. So everything can be easily represented using architectural design. And in the class design, user interface design, that will be used during the proposed methodology as well as the proposed research work models. So that will give you what is your core idea, what are the classes and other user interfaces you are using. The use case models will show you who are all the users, stakeholders, what are the main functions you are going to, how the interaction is happening, whether it is user friendly, is there any user interface design implemented effectively so that it produces more efficient result. So these parameters also you need to consider. That is a part of your chapter 1, 2, 3 as well as chapter 5. So the same way algorithm design also, you have to choose an existing algorithm or you can go for a new algorithm. Not only one typical algorithm. So if you take algorithm, there are only 5 algorithmic proposed algorithmic methods, like we will say divide and conquer, backtracking, greedy algorithms, graph-based algorithms. So the other latest algorithms like machine learning algorithms, AI, deep learning algorithms, artificial intelligence-based algorithms, all those things are combination. They are using the basic algorithms. So they may belongs to the KNN, RNN, CNN, all the algorithms and colony algorithms, SPM techniques. Everything is based on the typical algorithmic techniques like divide and conquer or graph-based or divide and what is that backtracking. These kind of algorithms are modified and added some new parameters and elements. And then they are showing the KNN, RNN, CNN, everything, shortest path registers, recursive algorithms. So everything is based on the core idea only. So you need to concentrate on the algorithmic design also. And if you go with only one algorithm, in each algorithm you have to identify what is the main core, what are the main steps followed, what is the formula behind that, what is the logic behind that. That logic will produce what kind of result. One algorithm alone, if you go, you cannot able to come out with because the same algorithm may be used by more than 1,000 research works. So if you follow the same algorithm, because they are predefined steps, you will get the same kind of result. If you want a newer new algorithm, you have to add some additional parameter. Say if you take the encryption decryption, there will be RSA algorithm, DSA algorithm, all those things. So what they will do, say they'll add one more parameter, MRSA algorithm or NRSA algorithm. So the N parameter they will add with additional feature. Nowadays also In deep learning algorithms, they are modifying the existing steps by adding some new constraints or logic, and they are renaming it into some other novel method. So you need to concentrate on the algorithmic steps also, because the algorithms are the predefined protocol. If you follow the steps, the same kind of result you will get. And the protocol design also plays an important role, because if your the logic is well defined, then we'll go for the protocol. So in the objective itself, you are going to state that these are the steps I am going to follow, or these are the methodology or algorithm I am going to follow. And if I follow that, I will get there. Once you define this is my proposed algorithm, you have to follow that. You cannot deviate from the steps. And then through the steps, and by proposing an advanced or novel, your own algorithm, you can come out with a new solution. So these are the things you need to consider while designing a research work also. You need to concentrate on architectural design, class design, user interface design, database design, algorithmic, and as well as protocol design. They are also part of your research work in the chapter 1, 2, 3, as well as chapter 5. And your actual work will be represented in chapter 4. The methodology, implementation, results, solutions, contributions, and findings, and justifying your results. And in the previous class itself, we discussed the principles leading to good design, because there are so many techniques day by day used in the corporate sector for different kinds of projects, because we have the software industry for the past 50 to 60 years. They tried with a lot of, they may created thousands of projects. In each project, they tried with a number of techniques, algorithms to reduce the cost, increase the efficiency, reduce the manpower, reduce the memory, efficiency, runtime, speed, all those things. So by everyday practice, by doing different kinds of projects, dealing with the different kinds of end users and customers, they fixed their own way of doing projects, or they are proposing the best practices, or they're showing the systematic approach for that leads to a good design. So what are those things means? So we need to fix the goals to achieve when doing good design. So we have to fix our goal. The same way in research also, you need to fix your title objective. So in every research work, there you should have minimum 3 to 4 objectives. The first objective may be related to the literature review based on the say chapter 2, and the second objective may be the method, algorithm, or the proposed model. It leads to chapter 3, and the actual implementation work, hardware, software, peripherals, and the actual implementation, coding, logical steps, that will be comes under chapter 4. So these are the things. So we need to fix goal 1, that is objective 1, 2, 3, or maximum 4, or if you want now, you can add one more, 5 also. So in every, after your coursework, all 4 courses, 2 specialization papers and 1 core paper and 1 research methodology, end of the first year, you are eligible to submit your synopsis. So in the during the synopsis stage, you will fix your title based on your domain. Then you need to fix the objectives. So the objective should be minimum 3 to maximum 5, because you are not doing a group project, so you cannot divide the objectives among yourself. You are doing this into individual or only one scholar per research work. So maximum you can fix 3 to 4 objectives. The first objective may be leading to studying the domain, understanding the various aspects of your research work, or doing the literature review. So it may, you can say, justifying or identifying the best method. The second objective may start with the actual method or methodology. Third objective, actual work and the results. And the fourth objective may state justifying the efficiency, and through some implementation or through some simulated models, or using some analysis tools and techniques. So like that, you need to fix them goals, or we can say objectives. So why we need goal, and why through the goal and objective only you are going to do the remaining work. Your actual work should be done to justify or prove the fixed objectives. So the goals to achieve when doing the good design, or increase the profit. The same way, In research also, you need to show an efficient or optimal from the available feasible solution. You have to show the optimal or best optimal solution, and ensuring that we actually conform to the requirements for solving the customer's problem. So the customers are in the industry, there may be a less efficient solution available. You are going to provide an efficient method or solution. And accelerating development, this helps reduce the short-term cost, helps ensure the software reaches the market soon. So you should, once your goals and objectives are fixed, you should not deviate from that. So after your objectives, some proposed model, literature review and proposed model. Then once your synopsis is approved, title and objectives are approved, you cannot deviate from the title, or you cannot deviate from the objectives. The next 2 years you have to work to just you can publish one paper justifying the first 2 objectives. That is literature review and case study and along with your proposed methodology. The second paper along with your proposed actual work, methodology, techniques, and implementation, and justifying the results. So like that, you need to publish 2 papers in SCI or Scopus indexed journals. First 2 objectives can be published as in one journal paper, and the remaining 2 objectives, methodology, implementation, results, and conclusion and findings. Those 2 as the second research paper. Objective 4 and 5, objective 3 and 4 as second journal paper. So you need to fix the objective or goal. According to that, you have to work out, and you should not deviate or accelerate. Then it will increase the cost, time, efficiency. We cannot once the synopsis is approved, objectives are approved. Next, only within 2 years you need to submit the thesis. The day of synopsis set up, the title and objectives are registered under the candidate name. So from the date of synopsis to the next 2 years, you have to submit your research. You have to go for the collegium. Within next 6 months, you need to submit your thesis. So that is the duration. So increasing qualities such as usability, efficiency, reliability, maintainability, and reusability. So the same way in research also, why we are going for some research means to increase the usability, to increase the efficiency, and to justify what you are proposing is more reliable, more secured one, and it is easy to maintain, and it can be used again and again for next 5 years or 10 years. So if those qualities are in your proposed or research work, then it is a good work. So usually any objective or research is based on reducing the cost, increasing the requirements, and fixing your objectives and goals, and not accelerating from that. Then your work should have the qualities like it should be usable by all kind of end users. It should have the efficient result, and it should be reliable one, trustworthy one, and it is easy to maintainable, and it can be reused in different sectors and domains for next another 5 years or 6 years or another, until the next technology comes. So these are the good principles. Fine. Then we already discussed the 10 design principles most widely used in the corporate sector in the previous class itself. So any doubts so far? I think we revised what we discussed in the previous class. I think we had the class on 28th or some 27th, on 26th, Saturday. February 26th we had. During that time, we discussed these concepts. So any doubts so far? What we discussed last class, we don't have the class. Any doubt so far? What we discussed? Any doubt? Is those topics relevant to your research work? Because you people are not BTech students or MTech students, but the topics are mostly studied in the UTech, BTech level, in object-oriented software engineering or object-oriented programming using UML tools, or in the MTech level, advanced OOAD, advanced object-oriented analysis and design, UML techniques. And you people are research scholars. You have to think about each and every aspect with respect to the research work what you are going to do. Any doubts so far? You'd like to ask any questions so that we can proceed with the left out topics, patterns, architectural models. Which we already discussed. The first design principle is divide and conquer. Second, divide and conquer is a well-known algorithmic concept. If the given problem statement is highly complicated, what we will do? We will divide the problem into n number of sub problems, and each problem should be in the unit level. So it should have only one task at a time. So we'll divide the problems into in such a way that it reaches the unit or event task. Then we will solve each and every task in the basic level. Then we will combine all the solutions, all the sub problems together to get the complete solution. That is called divide and conquer algorithm. The same concept used in corporate sector also to get the perfect result. And each subcomponent can work independently. It's not dependent on other sub problems. So that if any logical issue in each subcomponent, that can be resolved separately. That will not affect other subcomponents. So that is a divide and same thing. Whatever may be the domain or system, the framework you are taking, it may be highly complicated. It may have unsolvable problems, NP completeness, whatever it may be. You can the complete problematic statement can be problems and find out the solution for each and every subcomponent. Try to solve each and every subcomponent using different techniques, because we have n number of techniques. You need not follow only one domain. So I want to solve the complete complex system using artificial intelligence. It's not, then if you go only one method, one domain, you cannot come out with the new solutions, because there are n number of research going on every day, even in the industry as well as by the students, research scholars, so many different people. So they may use the same concept idea previously, it may be existing. So divide the problem space into so many sub problems. Try to solve each problem by using the more efficient. One problem you can solve it using AI technique. Another problem you may solve using some networking concept. Another problem you can go with some other operating system concept. So in that way, you can make use of, even you can solve some other problem using some mathematical or statistical models. You can solve some other problem using some math lab techniques. So like that, apply different techniques to solve the complex problem may belongs to only one domain, addressing the agriculture domain of identifying the plant diseases, or identifying the moisture of the land, identifying the minerals and other things, proposing an good crop for the given area. So you can identify what are the issues related with the particular domain, and each sub problem, say the leaf disease identification of the leaf, you can do it using image processing technique. The moisture, identifying the moisture and other concepts, you can solve using IoT technique, using sensors. And the cost issue, memory issue, and forecasting, remote access, that can be handled using some networking concept. So like that, you can apply different techniques, small different techniques to solve the application domain. Your application domain is agriculture-based plant disease prediction and giving some solution. But each problem can be addressed differently, and you can use different techniques and methods. And the analysis, statistical process, simulation can be done using MATLAB, and some other aspects, memory usage, because if it is IoT based system, continuously if they are monitoring the memory usage, storing of data, that can be handled using some operating system or networking concept. So like that, you can each aspect you can fix it in different objective also. So that is called divide and conquer. The second one is increase cohesion and wherever possible. Cohesion means be independent of other modules. Say in your solution, there are 4 modules if you are having the dependency among fixing among the 4 modules, if first module is solved, then only the second module, the output of first module is given as input to the second module. The once first 2 modules are completed, then only the third will function. There should not be such kind of dependency. So the cohesion should be, that is, dependency should be reduced and independency should be increased. Cohesiveness of functions should be increased so that they can function independently. And reduce coupling. Coupling means the functions or components, modules are highly dependent, coupled with each other. That should be avoided. And keep the level of abstraction as high as possible. So that's what you have to fix your boundary, fix the end user. You cannot do the soil agriculture project of plant disease prediction for all the crops, 1,000 rows and rows of crops. You fix, take some, you take a region, identify a village or the, say, the area or sector where the Bellary region, it's highly famous for only onions. Or if you take some other region, say the Ozu region, it's highly useful for that rose plants, as well as what is that, the silk mulberry kind of plants. So you identify a particular region, what kind of crops are cultivated in that particular region. You identify the disease related to only one or 2, 3 crops, and what are the issues they are facing, what kind of diseases alone attacked by the plants, in which season it's getting affected. All those parameters you have to analyze. So your boundary should be well defined. You cannot do it for all. You fix a boundary with the constraint, with respect to those constraints, do your research. And so it means abstraction. So you are taking the abstract entity, you are not going for the globalized one. Increase the reusability where possible. So you don't, it should work in all kind of devices. Like maybe it may support Android, desktop, laptop, iOS, and the same functions, concepts can be used again and again in different aspects. Also, it can be reused or it can be recustomized. It can be extended. Those usability aspects we have to consider, and reuse existing design and code where possible. So no need to go for new algorithm or new method, inventing a new system. Make use of the existing systems already used in different kind of, some concepts used in hospital industry can be used in the agriculture industry also. Some components and functionalities used in banking sector to solve an issue, memory issue, can be used in agriculture domain also. So the thing is, you take the existing concepts, algorithms, it may be used in different, some other domain, try to use in another domain by modifying the parameters or customizing the content. And design for flexibility, it should have the flexibility to extend, modify, update, or rebuild, change the hardware, software, or changing the front end, back end. So those kind of flexibility should be available so that it can be updated in near future. And anticipate obsolescence. You have to check how long your project can be used, how long it will be in the market, those things. And a design for portability, it should be highly portable. You should not need a big software, IBM, separate processors. It should support Android. It should be highly portable. Those parameters you need to consider. And design for testability. So you have to check during the initial state, it's you have to think about the reusability, flexibility, obsolescence. All those things should be considered while fixing the objective itself. So these are the best design practices. This we already discussed in the previous class also. And in the remaining slides, they gave you unclear idea of what is what. So divide and conquer, these are the aspects we discussed. And increase the cohesion and cohesion wherever possible. So it is, cohesion is highly independent, creating highly independent components. And different types of cohesions also we discussed. It may be layer level, communication level, sequential level, procedural or temporal utility levels. And coupling, so this is highly coupled one, it's minimal coupled. Then we reduced how we can reduce the coupling. by using the common control, stamping techniques, data, reducing the coupling among the data, routine calls. You can go for, instead of going for recursive call, you can go for call by value or call by reference, using the inclusion import, using external variables. So these are the different techniques we can make use to reduce the coupling among the components. Then keep level of abstraction as high as possible. So if you are going for classes and objects or object-oriented constructs, definitely the abstraction level will increase. Entities that take only the relevant and necessary attributes and functions. So both functions are encapsulated. Data hiding is implemented. Objects. So when you create, while going for implementation of research, if you go for object-oriented concepts like or C++, if you try to implement the object-oriented constructs like inheritance, polymorphism, all those things, definitely the abstraction will come into picture. And we should know one thing, the real-world entities can be easily represented using object-oriented classes and objects. And increase the reusability wherever possible. So the usability and reusability plays an important role. It should be used long. Consider the best practices, then only you can create a long-term project that can sustain in the market. And reuse existing design and code wherever possible. So you need not to create or generate a new code for the existing codes. The thing is, you should generate your idea, and the methodologies can be already available to implement the idea or the. So you need to analyze the problem. You have to identify the research issues and the research gap, and to solve that research gap, what kind of methodology you are going to apply, that you should identify. Once you identify the solution for that particular research gap, you can make use of the existing solution space. It may be a mathematical model, or it may be a graph-based model, or it may be a tabulated model, or it may be a coloring algorithm, or reusable algorithm, or a backtracking algorithm, or it may be IMLDL, any kind of algorithms already existing. Because if you go with the standard formulas, techniques, algorithms, well known or well used, definitely you can expect the, if you apply in formula A plus B, we will get this result of A plus B. You need not invent a new formula, or you try to reuse the existing methods and concepts, standard techniques. You identify an idea, a solution for the given problem. Then to solve that idea, to get the solution for that idea or novel approach, you make use of different solution space already available. And design for flexibility. It should always have the flexibility, create abstractions, hard coding or anything, leaving all options open, reusable code. So if your software is a software or idea is open source, it can be used again and again by different people. If your work is already published, other people may refer your research published, and they may cite your research in their own papers. So automatically your citations will increase. So that's what, when you identify some solution or some concept or idea, if you publish it is in the form of paper, and if it is available in a good reputed peer-reviewed journal, especially a CAA Scopus or IEEE or the, then other people will refer, download, they will go through. If they are impressed with your idea, they may cite you, they may reuse your idea, what you published in their work, and your citations will automatically increase. That is the idea behind reusability. Anticipate obsolescence. So any technology, any result may go in obsolescence after 1 year or 2 years, chances are there. So try to use the latest advanced concepts. So because you are starting your research work this year, and you are eligible to do the submit your synopsis end of this semester, maybe during July or August. Once your exams are over, your results are published, from July, August onwards, you are eligible for your synopsis. So when you start writing your synopsis, proposing your objectives, that time you have to choose your methodology and objective based on the latest techniques available in the market during the July, August. That time, the research problem, what you are trying to address based on the work which is published in 2022 or 23. Then only if you propose a method during 23 and your results and your thesis you are going to submit 2026, 24 or 25. So that time, and within next 2 years, so many changes, so many advancements will come into picture. So that time, so the maximum 2 years, after 2 years or 3 years, any technology may go in obsolescence. That's what you have to think about, how long the method or logic or the technology what I am proposing will sustain in the market. So that's what within next 2 years you have to submit your result and contribution based on the objectives what you fixed. Beyond that, anyhow, the technology, everything may change. Then design for portability. Portability means anywhere, anytime. It should be easy to handle, it should be easy to carry. It should be available 24/7 using cloud technology, using internet-based solutions, accessible 24/7. That is very important because that provides portability and testability. And that's what nowadays people are making any research work as open source. So anybody can give some additional advancement. Anybody can modify. Anyone can come out with new solution or modify or give some additional code. The open source softwares and the research works are open for testability. So these are the concepts we already discussed the previous class itself. I think no doubts so far. If any doubts, you can ask me so that we can proceed further. Any doubts so far?
Ma'am, I have a doubt.
Azhar, sir? Yes.
Ma'am, when are we supposed to submit our first paper, survey paper?
Now itself you are eligible for your survey paper, sir. So because you are in your research work. You already registered. You are there. Is given.
Okay,
but
now
this during the first year you are doing your coursework, and now you are eligible to submit your case study paper or literature review paper.
Okay,
and you can have your framework, you can have your objective, but the proposed methodology, proposed objectives, solutions for your objectives should be published after the synopsis. So after the synopsis only, provisional registration will be given for your title and objective. Now you are a PhD scholar doing your research course paper, coursework for first 1 year. Once your coursework 4 subjects results are published, you are eligible to submit your synopsis. In the synopsis, you have the title and your name, guide name. Then you will mention the objectives, and based on the objectives, you have abstract, introduction, then objectives. So in the synopsis presentation, they will think the title is relevant to your domain. Say you registered under CSE or ISC. Your title should match with CSE, ISC core concepts. Then you already studied 4 papers, especially 2 specialization paper, 1 core CSE paper, and a research methodology common for all the students. Research methodology also customized for CSE, ISC. The research methodology for civil mechanical may be somewhat different. The research methodology for CSE, ISC, CEEE may be somewhat different.
Okay.
So doing all those things, focusing on computer science and engineering or information technology domain. So what you study, especially in specialization 1 and 2, should match with your domain. Say you are going to do your research work on computer networks, there should be some advanced computer networks or DCCN or some paper related to that. Or if you are going to do your research topic based on AI, ML or DL, some other fuzzy logic or something, there should be 1 core paper, specialization paper with respect to those things. It means if you not studied those papers in UG, PG also, at least you are studying, you are preparing yourself for the proposed work. So in the
Okay.
synopsis, what they will check, your title is relevant to your domain, computer science and engineering. Objectives are relevant to the topic. And the paper, what you studied, what you completed, whether you scored enough mark in the core paper, all the 4 subjects. That is also important. Or
Okay.
qualifying yourself for the research. That also they will check. Then they will check for the objectives. The objective should match with the title. Then accordingly, you have to propose a research methodology and other things. So once the synopsis is accepted, initial internal synopsis presentation will be there with your guide, doctoral committee members, and one internal member.
Okay, ma'am.
Once it is approved by the internal committee, they will call the external member. In front of the external member, you have to give the presentation. And your synopsis report and PPT will be sent to the external examiner well in advance. They will go through it. During the synopsis, they will ask you some questions if they have any doubt. And they may give you suggestion to modify your title, modify your objective methodology. They will check whether it's already existing, whether the novelty is there. Then they will, internal, external, everyone will approve. Once it is approved, from the PhD section, they will issue an your PhD provisional PhD is registered under the title and topic under the guidance. Now from that date onwards, next 2 years, you can do your actual work. Within the next 2 years, you have to submit your collegium. Then in the collegium, the same examiner will be called. Once the collegium is approved, after the synopsis only, you have to publish your work with the implementation, with the logic, with the mapping to your objective and your methodology and contribution.
Okay.
So minimum 2 SEA or Scopus paper is must. That requirement is fulfilled, then they will call you for the same examiner for the collegium. In the collegium is accepted. Then you are eligible to, within next 6 months, you have to prepare your thesis. The thesis will be submitted to PhD section. They will send it to one internal examiner, one within the state, one to foreign examiner. So the result will come. Then they will conduct the thesis viva.
Okay.
So that is the procedure.
Okay.
So minimum 3 years, maximum 5 years. Otherwise, you have to re-register.
Okay, ma'am.
Yeah. Then we discussed the techniques for good decisions. So how we can make the decision very well. Our life is based on the decisions that we make. The same way during the research also, to take right decisions. Decisions should be based on the priorities, objectives, to decide among the alternatives. So from the available alternatives, you have to choose for the best optimal solution. Using cost benefit analysis to choose among alternatives. So you have to consider cost as one of the major parameter. Based on the cost factor, we have to choose the best among the low cost, high benefit, more efficient solution should be chosen. And our objective should be fixed based on the, we have to go for the methods. So all those things we already discussed in the previous class. Then we discussed good design document. So we can say it is, we can compare it with the thesis or synopsis report, or submitting of yearly report, 6 months report, all those things. So while submitting any document, say in thesis, synopsis, the documentation format, syntax, the structure, fonts, colors, numbering, citations, everything plays an important role, because the document what you are submitting should be universally accepted. So you should follow the naming standards, formatting standards, especially while submitting or publishing the papers. IEEE standards and internal ACM standards. Templates are different. You have to follow the templates. The templates and the formatting plays an important role. So the good design document should have the following aspects. So I think also we discussed previously. So if you take the structure of the design document, every document should have a purpose, general priorities, outline of the design, major design issues, and other details of the design. So we can directly map it with the thesis format or with the synopsis format. So the synopsis should mainly focus on the objectives or the purpose and purpose. What system or parts of the system this design document describes. So the template for synopsis is different. Half-yearly report is different. And the thesis report is different. Your PPT presentation report is different. Each is having its own format. Every university is following their own different templates. So we have to stick with the templates and formats. Minimum number of pages, maximum number of pages, line spacing, everything is an important one, because standards helps us your document reaches a global scenario, because once your thesis is accepted, you are awarded degree, your thesis will be available in the Shodh Ganga or Inflipnet website. All Indian universities, thesis is available in the Shodh Ganga. Have you, any one of you referred Shodh Ganga so far? Any idea about Inflipnet website, Shodh Ganga? Any one of you referred so far? I think the first class also I mentioned. So for anyone referred Shodh Ganga or Inflipnet website? Am I audible?
Ma'am, I've heard of it, but I've not visited still, ma'am.
If you refer, even our you can search. It's like a search. There you will get lot of buttons. You can search through the university, search through the author, search through the scholar, search through the guide, or search through the domain: engineering, agriculture, medicine, and mostly MTech, MPhil, PhD thesis will be available. All Indian AIU, Association of Indian Universities, all universities which comes under UGC, AICTE, AIU, government and private universities throughout India. Once the thesis is before awarding the degree certificate to the candidate, thesis or synopsis, what is the thesis, MPhil thesis or PhD thesis is accepted and presented. It means publishing. So usually the older days people used to call, once your thesis is accepted, before awarding the degree to you, your thesis should be published. So usually what they will do, they will send copy to the newspapers or some journal, or in the journal publication is not that much famous, at least 20 years before. That's why you are awarded MPhil or thesis, they will ask you whether your thesis is published. It means your work should be available online. That time online is not famous. That's what the university itself, they will publish it in the newspaper. Send them copy to the newspaper or the university journal or the AIU journal. Or at least they will say the student name, guide name, and title, which year, date, which university, so on student. That information will come in AIU magazine. So that is called publishing the thesis. So usually when they sanction the student Viva is conducted and so on so date by the university, they will produce a notice or order. It is awarded under this university, under this department. They will send an CC to newspaper, AIU journal, department copy, other nearby universities. So it means published. So nowadays, that's what they made. All universities throughout India, once the degree is approved for the particular student, after the thesis Viva is conducted, before creating the degree certificate, the thesis should be uploaded in the Shodh Ganga Inflipnet website. So you can find all theses, even our Jain University thesis so far awarded will be available. PTU universities thesis, MPhil thesis, PhD thesis will be available. Bangalore University, Anna University, except IIT's PhD and MPhil, MS thesis, all thesis will be available in all domains: medicine, agriculture, MBA, I2IT, IIM, IBM, all thesis will be available in Shodh Ganga Inflipnet website. Complete thesis from the first page to wrapper page to last wrapper page, last page, it will be available along with the seal and sign of the original signed sealed within the thesis, also in between the thesis, every chapter they will put the university seal. The first 2 pages will have the student name, student signature, guide signature, examiner signature, sign and seal. In each chapter also they will put the seal, university original seal, and scanned copy will be uploaded in Shodhanga. So because it should be available and the standard format should be followed. That's what standard format means. It should have the complete information. The following element should be there in any document. So the purpose should be there. General priorities, general descriptions, keywords, abbreviation should be clearly defined. Outline of the design, it means a table of content, format, number of chapters, figures, abbreviations, appendix, number of figures, number of tables, everything should be clearly mentioned. Major design issues, any diagrams, any other constraints, additional annexures should be clearly mentioned. And other details of the design like chapters, implementation, snapshot, page numbers, abbreviations, everything should be clearly mentioned. So the universal standards should be followed. Then the next concept is called design patterns. We already discussed what is pattern. Pattern is a blueprint, or we can say it is a mold. It's mainly used in the, say, protocols are there. Protocols will give you the systematic algorithmic steps. Based on the protocol or predefined steps, the graphical model is created using patterns. So within patterns, there are a number of different types, because the patterns are fixed steps. If you follow the fixed steps, we'll get the standard same output. Say if my pattern is or mold is a elephant figure, then whatever material, I may put the gold, or I may put the silver, or I may put the plaster of Paris, the appearance, the image or the statue or the ideal, what we are going to get is elephant only, because the pattern is made of elephant. If I am using a pattern of a child, it will always produce the child output. So choosing a pattern, same way the method and methodology or algorithm also, how to choose that best fits to your objectives, domain, and what kind of steps you want to follow, what kind of output you are expecting. So based on the output, based on the input, so what kind of output you want, accordingly you have to follow the methods. So if you take the patterns, the recurring aspects of the designs are called design pattern. Pattern itself is a recurring aspects. So the one pattern will produce the similar type of output, or we can pattern is an object. Pattern is an that produces enough similar instances of object. So the pattern is the outline of the reusable solution to the general problem encountered in a particular context. So if you are facing a general problem and you want to solve the problem again and again, to solve the pattern, many system software developers to use, because the patterns are doing the same systematic. So the systematic steps will be repeated in a good pattern should be general as possible, contain a solution that has been proven to effectively the problem in the context. So it will solve for accordingly to solve the context problem. We are going for pattern that and again, say for example, you can see the traffic. So we are facing a lot of traffic issues. So the signal is framed in such a way that there will be green, red. Visible?
No, ma'am.
Visible now?
No, ma'am. No, ma'am.
No, ma'am.
Visible?
No, ma'am.
It is visible now.
No, ma'am.
Now visible, ma'am. Again gone.
Now,
No, ma'am.
Now visible.
visible now.
Yes, ma'am.
Visible now. So, how many classes for you actually? It's, today is our last class now.
Yes, ma'am. I think.
Now it's visible.
Yes, ma'am. It's visible.
If you take any, if you take any pattern, the pattern should contain the following elements. There should be a context. It should solve one problem. Forces or the solutions. What is going to solve should be clearly mentioned. And every pattern should have its own anti-pattern. If the pattern goes wrong, say if you are taking a medicine, if it causes and solve the issue, things you need to take now, kind of thing. Anti-pattern side effects.
Ma'am,
how
we
to
can see
solve
only
side
the
effects should
first
be
slide.
mentioned. Slide.
Yeah, ma'am. Now it's fine.
The pattern description is there. Slide see now is there.
Yes, ma'am.
What is the heading of the slide now?
Pattern description, ma'am.
Yeah. So there should be some anti-pattern. And what are the other related patterns? If that pattern is not working, what are the other relevant patterns? So what are the other feasible solutions? So you're choosing the best optimal solution. Other than the optimal solution, what are the other relevant feasible solution? And the references. So the same applicable to research work also. So research work also like pattern only. So it may repeat in different questions. So the context, solution, anti-pattern, related pattern references should be there in any pattern. And then patterns, you can, because it is pattern, depending upon the input, it will produce the same kind of, we can say a pattern is like array. So in array, all the elements will be of the same type. Only the position value differs. The description is, definition is same. So based animals. So there are different types of. So if I put on mold, so nowadays we are then making the plastic chairs and products now. So they will have, they will put some mold. So they will produce a number of 1,000 chairs, 2,000 tables, plastic. So they will use, what is that? Plastic industry, Supreme Industries mold, plastic mold they are generating. So you have to follow a particular pattern to produce, depending upon the problem and domain space, you have to choose the respective pattern. So there are a number of patterns available. These are the well-known, well-used patterns types. The first one is Abstraction-Occurrence Pattern. Second one, General Hierarchy Pattern. Player role pattern, Singleton Pattern, Server, Delegation, Adaptor, Façade, Immutable, Read-Only, and Proxy Pattern. So these are the like methods and methodologies. There are a number of things available, but they are well known and well used. So actually they given you almost 11 patterns for your reference, and it's widely used. What is abstraction? So the abstraction patterns are mainly used based on the context. In which context you are going to, we can say the domain or the kind of application. So based on the context, often it is domain model. So you find a set of related objects, and members of such sets share common information. So if it is having common information, say for example, what is the best way to represent such a set of occurrences in a diagram? So you are creating a class diagram. If you want to generate a number of objects from the class diagram, so this abstraction occurrence pattern can be used. And you want to represent the members of each of the occurrences with duplicating the common information. So the occurrences, each object will have the same information with the duplicate common information. Say the all students will have the same information. Every student will have the name, username, and the number of subjects will be common. Marks will be in the same range. So the same occurrences will happen. So usually the abstraction occurrences patterns are usually mentioned. Abstraction occurrences. So the TV series, each one series will have a number of episodes. They will have the same characters, same kind of scenario, the background. So the background, the general characteristics will not change. They will maintain the character role. They will maintain the domain, the house, environment. So the relationship, everything is, and the episode is the best example for abstraction occurrence. So they will have the TV series will have the title, and say the book will have the all those information. In the every library item, they will have the same. There will be a number of copies. Same way, they can have library item like title. Say the if you take the particular a book in a particular library, so it will have maybe Dick or travels. Say for example, for this particular book, it may be published by the same editor or it may be different edition. The same way, the title, it will have a number of copies in the title with the same title, but all will have the same content. And they given you one more example also. Aggregate abstraction. So one to many relationships. Say for example, scheduled train. There will be a number of train. There may be some special trains. The train will source and destination place is almost, and they will stop in each station. So the trains, what is the starting time, what is the end time, source to destination, how many coaches, number of seating, everything is almost fixed. Without and if they are within the same train, during some seasonal time, they will add some special trains from the with the same source to destination. So this is an example for abstraction occurrence pattern. The same way, if you take general hierarchy pattern, in which context we can make use, means objects in a library hierarchy can have more or one or more above, and some objects cannot have the subordinates. Say for example, represent a hierarchy of the objects. So there will be a number of objects, but there will be some hierarchy, base, derived, sub-derived, like that. Say for example, if you take we have the node, superior node, and say for example, if you take the employees, there will be secretaries, technicians, managers, and within that there will be a list. We can show them using list button or labels, panel, window. Say for example, here.
Ma'am, I have one doubt.
Yes.
Ma'am, if I have a complex design,
yeah.
If we use abstraction pattern, will the complexity be simplified, ma'am?
Abstraction, the complexity may be high, but you are taking only the relevant data. If you go for abstraction, it will there may be thousands of parameters associated with the particular thing, but you are taking only relevant, which is needed for your implementation.
Okay, ma'am, fine.
So this particular event box, so we have in a book, we have a number of chapters. Within the chapter, there will be a number of subdivisions. So you can click the options. So this is a hierarchy. So you have the book. Within the book, there are a number of chapters. In each chapter will be 1.1, 1.2, 1.3 subdivisions. So it shows the clear hierarchy, complete book, chapters, within the chapters, headings and subheadings. So here also they given and the video recording, audio recording, and within the audio there will be some categories: classical, jazz, rock, all those things. So if you take the player role pattern, it's mainly used for if the objects are having well-defined role to play. So a role is a particular set of properties associated with an object. An object may play different roles in different contexts. So if he is there is a human being in a serial, in home he may be a daughter. If she goes to the college, she will be a student. When she goes for and playing some game, she will be a team leader or batch. What is that game? She is playing some volleyball or something. She may be the volleyball team leader. So her role changes in different contexts. She is a daughter in his college. She is a student or PG student in football or volleyball match. She is a team leader. So like that, her role changes, character changes. Say for example, if you take an student attendance role, she is a student, and in an attendance role there will be one student, or there may be, while mentioning the student, will have the full time. She may be a full-time scholar, or she may be a part-time scholar, and she may be a graduate student or a PG student or UG student or a PhD student. But student, there is only one student. Her role is different in different context. She may be UG student or PG student, or she may be full-time or part-time. She may be maybe in some other teams, sports, cultural clubs. Her role differs. And for this player role pattern, merge all the properties and behaviors into a single player class and not have the role classes at all. Create roles as subclasses of the player class. If some issues arises to handle the exceptional conditions, we will go for the anti-patterns. In that case, these are the steps we need to be taken to resolve the issue. The fourth pattern, first one is abstract pattern, second one is role play pattern, the fourth one is singleton pattern. The singleton pattern can be used very common in find classes for which one instance should exist. So if you want to create only one instance of the particular context or the particular class, in that case you go for singleton pattern. If the domain is college domain, there will be a number of students, then you will go for role play pattern. If the person wants only one occurrence in your work, in that case you will go for singleton pattern. How do you ensure that it is never possible to create more than one instance of the singleton pattern? So if you are going to create only one instance for the particular class or class, in that case you go for singleton. The various forces are the use of the public constructor cannot generate that no more than one instance will be created. The singleton instances must also be accessible to all the classes that require only one object, and same object will be used to prove the process. So that kind of activities or the scenario, we can go for singleton pattern. Say for example, here they are given a company may be here. The company is having only one branch or franchise, or in that case, a company with the companies and functions get instance, and that will do all the process and it will get back. So if you take the observer pattern, in which context we can use of observer pattern means when an association is created between two classes, the code for the class becomes inseparable. And if you want to reuse one class, then you have to reuse the other one. So here, there will be, the problem is, do you reduce the interconnection between the classes, especially between classes that belongs to the different modules or subsystems, or in which the various forces can be, you want to maximize the flexibility of the system to the greatest extent possible. Say for example, there are two objects or instances, and if you want to create the association between them instances, or if you want to reuse one class, in that case we'll go for observer. The code for classes becomes inseparable. Association is created between the two classes. So there is one class, one more class is there. Say for example, in a composition, the engine is part of the car. So without the engine, the car cannot run. So there is an association. The same way, but the car is a base class, engine is subclass. Say for example, you take a human class. Within the human class, we have the instances. Say for example, the human being is having one brain, one heart, like that. So without one brain, without one heart, he cannot be a human being. So there is an observation, the association between the classes. From the base class human, derived class brain, derived class, only one instance, one heart, one brain. Without brain and heart, the human is incomplete, like that. Say for example, they given the instance observable, forecaster, observable, weather, viewer. So if you're in temperature monitoring system, the components like forecaster, weather viewer, they are all the parts of the weather monitoring system. So it will observe what is the temperature, what is the time, humidity, rainfall, and the force of the wind. All those things will be observed. So in the weather observable, there are forecaster and weather viewer. They are all observers. They are associated with each other. The relationship between those two is many to many. So it will take in different instances, different time, it will observe the time, weather, what is the time, what is the weather. So each and every second you can monitor the weather. And the anti-pattern for observer is cannot an observer directly to an observable, so that they both have references to each other. So we need an observer as well as observable. Then only we can relate each other. Make the observable subclass of the observable. So the observers will be part of the observable. The next pattern is a delegation pattern. The delegation or designing a method in the class, you realize that another class has a method which provides the required service. Inheritance is an appropriate. Say for example, because the rule does not apply. Say the problem is you must most effectively make use of the method that already exists in other classes. You want to minimize development cost by you reusing the methods. So you will make use of the existing methods from an available modules, and for a particular process or event, you need not create your own code. So if the result is already available, say for example in macros, so the macros can be used wherever possible without reusing the code. Say for example, they given you the example booking flight reservation system. They are booking for a flight, so they will identify the specific flight and regular flight. So the reservation system booking process is the base class. From the booking itself, there will be special flights as well as regular flights. You can choose the ticket from the regular flight or from the special flights. In the train also, there will be regular trains and special trains. So based on your timing and based on your need, you can go for the special flight or in the regular flight. So the flight number, both will have the same. So here, if you go for flight, special flight, it means it's a delegation. So delegation means delegates. Functions we are calling the delegates. What are calling the delegates? Usually the delegates will be from outside they are not part of the organization. We'll call from some other factory or some other organization, so that we are giving preference to them, but they are also related to us. They may be specialized in our domain. We need some idea from them. So the same way in delegate patterns, there will be normal classes and objects functionalities available. Instead of making for some special delegates or special flights or special trains, depending upon the need. it may suit your timing or it may suit your cost. The tickets may not be available in the regular one. So based on some need, we are going for delegation pattern. And in the delegation pattern, things over generalization and inherit the method that is not reused. And instead of creating a single method in the delegation, does nothing other than the call method in the delegate. So the same function is available in the normal pattern also. Instead of using the normal pattern, we are going for the delegates to reuse the existing code. And the next one is called Adaptor Pattern. You are building an inheritance hierarchy and want to incorporate it into an existing class. So you want to add some special feature or some additional parameter or going for inheritance. The reused classes is also often already part of its own inheritance hierarchy. So the existing classes, base classes is also part of that. And you are creating a new special one that is part of the inheritance hierarchy. Problem: how to obtain the power of polymorphism when reusing a class call methods. Have the same function but not the same signature as the other methods in the hierarchy. Say for example, you do not have access to multiple inheritance or you do not want to use it. So in the adapter pattern, what we will do, usually the adapter means, say it's a kind of virtual function or front function. It may be part of the class or it may be having the access rights to you may use the functions and variables. So the virtual functions as well as front functions, they may not belongs to the same class, but they are friend to the base class. Say they given you an example here, the shapes class. We have a shape of 3D, volume, sphere, and torus. So here they are creating an one more node. So in the function volume, return adapter calculate volume. So here we are calling calculate volume. The function is called through the torus class. So here the instance is, so here they are adopting a special function, and this adopted function is called through the derived class. The next function is called Façade. So Façade means often the application contains several complex packages. So any application will have a number of packages. The programmer working with such packages has to manipulate many different classes. Say for example, the problem: do you simplify the view of programmers have a complex package? And as well as forces, it is odd for programmer to understand and use an entire subsystem. If several different application classes calls methods of the complex package, then modification made to the package will necessitate complete review of all those classes. So Façade patterns, when we will use means, say for example, in an airline reservation system, we have the airline, we have the functions like find flight, booking, delete the booking. In that case, so we are going for regular flight or a normal flight. In that case, so we are creating an Façade from the base class airline, the regular flight, or it may be a special flight with the package of, say, because the airline reservation system is a highly complex system with a number of functionalities: regular booking, cancellation, rebooking, changing, timing the flight, changing the flight, changing the timing, rescheduling, all those things will be there. To simplify the process, we are going for the Façade in such a way that if a cancellation is done, the rebooking will be done in the same flight with some additional charges or in other flights. That kind of Façade is given. The next one is called Immutable Pattern. Immutable object is an object that has a state that never changes after the creation. So you're creating an instance of the class object. The object instance, the date, time, parameters, everything is fixed, that cannot be changed. How do you create, say, a class whose instance is immutable? Say for example, there must be no loopholes that would allow illegal modifications of an immutable object. So you want to fix some fixed value, the one instance you want to record permanently. In that case, we'll go for immutable pattern. Say for example, the solution to that constructor of the immutable class is the only place where the values of instance variables are set or modified. So to give more importance to the implicit constructors or explicit constructors while generating the object. Say you're initializing an object of a class. So during the time, the corresponding constructor will be initiated. That will fix the initial values. So the initial values will be in the constructor itself. We will fix the values. Say the object ID is 1 and its name is object, and these are you are creating a static object with the constant fixed values. Say, for example, in the same airline reservation process, so they are initializing from the flight booking 1 to many relationship. So there may be a number of passengers for the regular flight, and there will be a number of persons associated with the same flight. So the values will be fixed and it cannot be changed. And the next one is read-only pattern. Here, read-only pattern also, like we cannot change. It's in static. You know very well, read-only files means the values are fixed. It may be in PDF form. You cannot edit the content. You can open the file in the read-only mode. It means you cannot edit anything or you cannot change anything. You sometimes want certain privileged classes to be able to modify attributes of the objects that are otherwise immutable. Say to create a situation where some classes see a classes as read-only, whereas others are able to make modifications. Some parameters or classes need to take constant values. In that case, we'll go for read-only interface patterns. So the example is given here. Say, for example, there is a person, his name is fixed. Say the other ID, name, date of birth, parents, father name, mother name, they're all fixed. We cannot change. Or the customer ID is fixed, or the USN number or unique ID is fixed. The primary key may be for the particular object is fixed. So you will create a mutable person, first name, last name, surname, all those things will be given. The anti-pattern is make and read-only class, a subclass of the mutable class. Overall methods that modify properties such as through the exceptions. So if they want to change the values, it will generate the exceptions through on catch. The last one is called the read-only interface pattern. So read-only patterns, the values are read-only. Last one is called proxy pattern. Say often it is time-consuming and complicated to create instance of that class. So if you create, say in a class there are 100 students. If you create in 100 objects, say you have a class called student, you want to create 100 students instances. So it is it need to, the object should be initiated and the memory should be allotted. Initial should be in times. The constructors need to be executed. Memory allocation should be done. All those things take time. So there is a time delay and complex mechanism involved in the creating the object of the memory. To resolve that, how to reduce the need to create instances of a heavyweight class. So to reduce the instances of the heavyweight class, we are going for proxy. We know very well we have a proxy VPNs we used to create a VPN address. So it means that we are creating, we are hiding our MAC address, we are hiding our URL. So we'll go for virtual private networks. The same way, proxy will be enabled or disabled depending upon the need. So the force is, we want all the objects in a domain model to be available for programmers to use when they execute systems various responsibilities. So the domain name, DNS, and the MAC address, URL should be available. It is also important for many objects to persist from run to run of the same program. So if you are running the same program for a number of times, so you need to create the objects again and again. So if you are creating an array of objects, so each time it will need to, it will spend some time to create the instances and the memory allocation. To avoid that, we are going for proxy. So how the proxy pattern will look like means, so we'll have the client and the proxy will be used. through the proxy, a interface class if will be generated. From that, the heavyweight functions will be simplified. A client to proxy will be many-to-many association, and a proxy to heavyweight will be 0-1 occurrence. So any doubt with respect to the different patterns discussed? So far we discussed 11 patterns. Each pattern is having its own context, scenario, and problem space and solution space. So according to the application, what we are going to, according to the domain what we are going to use, we have to choose the appropriate patterns. Patterns are like models that will give an idea how, based on if your objective idea, domain, research space is mapping with any particular pattern, you can follow the pattern steps. So you can design your diagrams, use case models, everything based on the pattern description. That will give you a complete framework. Because if you are choosing, if you are going for your own architectural model, your own use case model or object-oriented diagrams, chances are getting some mistakes. The examiners may find some defects in your representation. So if you go for the models, if you go for the algorithmic steps, if you go for the patterns, if this is the pattern, the various parameters, each and every parameter notation is well defined. The complete description is available. The same description, if it is already designed for a flight reservation system, you can customize it for your own application like agriculture domain or plant agriculture based plant disease prediction or smart agriculture process. So the next topic is called software architectural models. So you know very well architecture means diagrams, architectural diagrams. So what is software architecture means? It is a process of designing the global organization of a software system that includes dividing the software into subsystems and deciding how those will interact and determining their interfaces. So what is the architecture of your process? What are the subsystems associated with that? And how they are interacting with each other. What is the interfaces? So importance of the software architecture, you have to develop a model to enable everyone to better understand the system, to allow people to work on individual pieces of the system in isolation, to prepare extension of the system, to facilitate reusability. So it means, so if it is architecture, it's a system. Each subsystem should be independent component. Each subsystem will be given to different people, and there should be option for extension mechanism. There should be option for usability, reusability, as well as testability. If you take the content of the software architecture, the architectural model should have logical breakdown. So the components should be connected logically, and each subsystem should have a role as a logical connection. Interfaces among the subsystems. There should be interfaces or connectivity among each subsystem. Dynamics of the interaction among the components of the runtime. So during runtime, component should have its own role and it should change dynamically. And the data that will be shared among the subsystem. What is the data that is given as input output from the subsystem? The components that will exist at runtime, and the machines or devices on which they will located. So what are the components? What are the components? How the components are working? What are the associated hardware components and peripherals? What is the framework? What are the devices? They say the Bluetooth, printers, scanners, cloud, everything should be routers, switches, everything should be clearly mentioned in the architectural diagram. You take the developing and software architecture, start by sketching an outline of the architecture. So for any research work or any particular project, the architectural diagram should be drawn by taking the outline. So you take the overall outline. Your architectural diagram should represent your complete research work. Take the outline, and based on the principal requirements of the use cases, identify the use cases, the requirements, determine the main components that will be needed to represent the use cases and the requirements. What are the components you need to identify? Choose among the various architectural patterns. So requirements, use cases, Accordingly, we'll go for the components. Then according to the components, we go for the patterns, put all those components into the pattern, and have several different teams independently develop first draft. So the architectural design can be made in different iterations. So we create an initial draft version, modify, update, and go for the final version. The same way, during the refinement of the architecture, identify the main ways in which the component will interact, the interfaces in them, decide how each piece of the data functionality will distributed among the various components, determine if you can reuse the existing framework you can build the framework. So once you identify the use case requirements, you go for the components, then accordingly go for the patterns. Once you identify the patterns, redefine the architecture. While redefining the architecture, identify the interfaces between them, data and functionality of each piece and the various components, and try to reuse each and every component and the framework and create the complete framework. Say, for example, describing the architecture using UML diagram, they given you in the UML, there are some diagrams like packages diagram, component diagram, and deployment diagram. Using this component diagram, deployment diagram, packages diagram, you can easily draw the architectural model of your research work. Say here the packages diagram, you know very well, the packages will have the rectangle with some suitcase fold. So the client is a package, common package, and a simple chart. So this is one package diagram. Another OCSF, here also there is a client, there is a server. So this is one component, this is another component, all components put together. So this particular simple chat application, this component is interacting with a client component. It may be a chatbot, or it may be a client server application or chatting application. So one user is chatting with another user. So this is represented using a package diagram. So this is one package. Say a simple chat is a package. It is the package suitcase kind of structure, rectangle with the suitcase. What is that? One more subdivision. This is one client package, common package, OCSF package. This OCSF package, we have two packages like client and server. So how we can describe using UML diagram means client is one package and server is one package. Within the client, we have one component diagram. So this is one client is communicating with server. Each client side also we have a number of peripherals, routers, Wi-Fi, switches, all the modems, everything. In server side also we'll have a number of nodes, routers, switches, main server, other sub nodes. Everything will be there. In the deployment diagram, the complete environment is shown. So the TCP/IP protocol, machine 1 with a number of clients, machine 2 with the server, and we have the GPS device, geographical positioning system. And the GPS device is connected with the machine 1 and machine 2 through the wireless communication. Machine 1 and machine 2 is communicating with each other through TCP/IP protocol. In machine 1 also we have a number of components. Machine 2 also we have a number of components. So if you take within the architecture also, we are using patterns. So they are all called architectural patterns. So here in architectural patterns, we have why we are using architectural pattern means the notation of patterns can be applied to software architecture also. So we can have patterns in architectural model also. So instead of generalized architectural diagrams with the rectangle squares and connecting each other, putting each and every component in an architectural diagram, we can have fixed patterns for architectural diagrams also. Say the different architectural patterns are multi-layer architectural pattern. So multi-layer means there will be a number of layers, layer 1, layer 2, layer 3, like that. And the client server pattern, we know very well, there will be a client, there will be a number of clients. The clients will be attached with the server. There may be one server, a number of clients, or a number of servers attached with a number of clients. And broker architectural pattern, transaction processing architectural pattern. Usually the transaction processing architectural patterns are used in the B2B, C2C, that is customer to customer, business to customer, business to business, customer to business, especially the online trading process. Transaction means always buying and selling. And the pipe and filter architecture, it's widely used in the Unix inter-process communication steps. Pipeline processing will be there. The filters will be generated. And model view controller, MVC architectural pattern. So this MVC architectural pattern, pipe and filter architectural patterns are a different kind of patterns. It's having its own unique parameters, scenario, context. So mostly they will ask you questions based on this kind of unique topics. So these are the 6 different types of architectural patterns. So initially we discussed 11 pattern types. Then we discussed what is architectural pattern. Within the architectural models also we have patterns. Within the architectural we have 6 predefined architectural patterns available. The architectural patterns are general, well-known, well-used models. So the multi-layer we know very well, client server we know very well, broker architecture will be there, broker and client will be there, transaction processing is widely used in e-commerce, and pipe and filter is widely used in the Unix, Linux operating systems and multi-processing systems. Model view, MVC, architectural patterns are used in most of the domain-specific applications. So now we'll discuss all patterns in detail. Say what is multi-layer architectural pattern means. In a layered system, each layer communicates only with the layer immediately below that. Each layer has a well-defined interface by the layer immediately below. The higher layer sees the lower layer as a set of services. So there will be high layers and a number of service layers. A complex system can be built by superposing layers and increasing the levels of abstraction. So when you go into deep, the abstraction level will increase, like deep learning and CNN algorithms. It is important to have separate layer for user interface. So user interface plays an important role. A separate layer is maintained for that, especially in multi-layer architecture. The layers immediately below the UI layer provides the application functions determined by the use cases. So user interface layer is always attached with use cases, and bottom layers provide general services. So the application layers, general service layers like network communication, database access is provided by the bottom layers. So the diagram shows you how the multi-layer architectural system functions. Say we have the application program, screen display facilities, user account management, file system. Then we have the kernel handling processes. Say for example, if you take in an ATM process system, so we'll have the front end. And through the front end, the user is interacting with the system. They will insert the debit card. They will see the welcome screen and they will enter the password. Password authentication will be done. Then they will do some transaction, credit or debit. It will access the file system from the back end, and the transaction will be done. Then accordingly, it will the operating system access, database access, network communication access, everything will be done. If they are debiting the money, the balance will be updated, money will be dispensed, and in the back end, concurrently, it will update the current balance. So these are the various layers involved in the multi-layer architectural pattern. Layer 1. So this is main layer, like recursive, or we can say nested for loop. Main for loop, next to for loop, next to for loop, next to for loop. So you want to repeat the process, you want to do any other transaction. So innermost process, outermost process, first process. So opening brackets and closing brackets. So they are levels. First layer, second layer, third layer, fourth layer, application layer, processing layer, transaction layer, database layer. So like that, so many layers are involved. So if you take the multi-layer architectural pattern, here also we can make use of all the 10 design principles. Here also they are using divide and conquer technique, increasing the cohesion, coupling, increasing the abstraction, reusability, increase the reuse, increase flexibility, anticipate obsolescence, design for portability, design for testability. All the 10 properties of best design practices are available in multi-layer architectural patterns. Say for example, for your proposed research work, if you are choosing multi-layer architectural pattern as a framework, then you have to consider all the 10 parameters. Am I implementing divide and conquer? Am I increasing the flexibility? Am I going for the portability? So if those things are implemented, based on the architectural pattern, then only it is an well-designed one. The next one is called client-server architectural pattern. So there is at least one component that has the role of server, waiting for them to handle the connections. So there will be one server, a number of clients. There is at least one component that has the role of client and further extension of the peer-to-peer connection. So there will be a number of clients. They may be peer-to-peer. So we know very well there are client 1, client 2. The client themselves, they can exchange the messages and they can communicate. And both the clients are connected with the server. And the server will have some additional special features, software responsibilities. So the data will be updated to the server, and they may access the software and other component tools and databases from the server also. So especially in the MNC companies, in the multi-layer architectural model, or if you want the distributed environment, the client-server architecture is used. And in client-server architecture also, if you are going for this particular architectural model for your proposed research work, you can expect maximum 8 design principles. We saw the 10 design principles, now best principles, out of which 8 you can attain. Why? Because in any distributed environment, especially if it is object-oriented database management system, we are following the CAP theory. What is CAP theory? What is CAP theorem? In the organization, BMS or DBMS also we are using ACID properties. Normalized table, DBMS or DBMS will come under ACID properties. The same way object-oriented database systems will come under CAP theorem. Say the MongoDB, CrunchDB, Neo4j, Cassandra, Hadoop framework. They are all come under CAP theorem. What is CAP theorem? Same ACID properties also will put it in ACID. That is 4 dimensions. This CAP theorem is 3 dimensions. A, C, A, P. C is consistency, P is persistence, D is latency. So at a time we can able to attain only 2. The third parameter we cannot able to attain. So there will be always some drawback in the CAP. So that's what we can able to attain only 8 properties. But in the previous one, multi-layer, we are attaining all the best practices. But in the client server, we are attaining only 8. The third is called pattern. So here, transparently distributed aspects of the software system to different models. Object can be call methods of another object without knowing that is object is remotely located. CORBA. CORBA is a well-known open standard that allows you to build this kind of architecture. CORBA is also in software, or we can say it is a database management system like DB2 CORBA, Scrum, SCRUM, Scrum. They are all different systems. They are mainly used in pair programming, extreme programming, agile process, especially in the SAP network, SAP as well as peoples of kind of large databases. Say here, they are using the client with Proxy, and there is a broker client, that is broker architecture, and there is a remote object. So the remote object is connected with the broker, and through the broker, it is connected with the client. The client may use some proxy server also, so that especially in the blockchain as well as in the cryptocurrency, this kind of client broker architecture, the online games, online rummies, especially in the share market, third party interference, wherever the third party interference, you cannot directly deal with the client. So in those kind of architectures, broker architecture is used, especially CORBA, PeopleSoft, SAP. The service provider will be SAP, but they will be providing the services to the end user through some broker or some customizing manager. And the next one is a transaction processing architectural patterns. So you know very well transactions means a transaction input. It is a package and it is connected with a transaction dispatcher. It is connected with a handle for flight reservation transaction, handle for flight cancellation transaction. So here also transaction, they are talking about online booking system. So you can sometimes you can directly go to the flight. Say if I am booking a ticket through AirAsia, I can go to the AirAsia website. I can book directly, or I can go to what is that Redbus, Yatra. There are GoHair. There are so many other service providers, brokers. Say the same way omnibus ticket booking also nowadays you can have an account with Redbus or yatra.com. What is that? There are the Clear My Trip, Make My Trip. There are so many service providers with so many facilities. You can cancel anytime, you can pay on advance, or you can make use of the points, bonus points, credit points. You can go with, you can travel, you can pay later. So like that, they are providing a lot of services. So we are dealing with the transaction processing is done through a third party. Say a process reads a series of inputs one by one. Each input describes a transaction. There is a transaction dispatcher, and that is this dispatches the procedure call or message to one of the series of components that will handle the transaction. So we have the transaction input and transaction dispatcher handle the reservation process. So the transaction processing is always a credit and debit process, buying and selling process, or it may be customer to customer, customer to distributor, or business to customer. C to C, B to B, A to A, all those things. So here, if you go for the transaction processing architectural pattern, you can able to attain only the 5 best practices. So it provides only 5 best practices through this particular pattern. And if you take the pipe and filter architectural pattern, a stream of data in a relatively simple format is passed through the series of processes, each of which transforms some way. So each process performs some task, it does some transaction. Data is constantly fed into the pipeline. So we are doing the pipeline process with a number of parallel processing. And the process works concurrently. So concurrency is maintained. The architecture is very flexible. Almost all the components could be removed. Components could be replaced. New components could be inserted. Certain components could be recorded. So that is the main advantage of pipe and filter. We can go for parallel processing, pipeline processing, and we can add and delete the components. And mainly it's used in Linux and Unix operating systems to achieve the concurrency and efficiency. The diagram shows you pipe and filter architecture, encoders for microphone. Say they have a cancel echo, cancel noise, remove non-voice frequencies, equalize the dynamic range, compress, transform, decode for speaker input, encode for ambient noise, decomposes. So these features are implemented, that audio system, various components are implemented using pipe and filter architecture. So say for example in Google, what is that, Microsoft Teams, Google Meet, as well as in the Zoom also, we have so many features like audio, video, audio on encompass, background change, increase the voice, the speaker. So these kind of various pipe and filter, especially the streaming, live stream processes, as well as image-based processing, as well as if you want multiple choices, enabling and disabling so many choices. Those kind of processes can be easily handled using pipe and filter architecture. So here, pipe and filter architecture, you can able to find 9 best practices. So these 9 best practices can be efficient, profits and benefits can be attained through the pipe and filter architecture. And the last architecture is called MVC architecture. The architectural pattern uses to help separate the user interface layer from other parts of the system. So the user interface layer alone is maintained separate, and other layers like transaction processing, networking, and communication layers can be maintained separately. So the model contains underlying classes whose instances are to be viewed and manipulated. The view contains objects used to render the appearance of the data from model of the user interface. The controller contains the objects that control the handle the user's interaction with the view and model. So this MVC itself, model, view, controller. So we can model your own architectural model, and you can view the model, and you can control the model. So M means model, V means view, controller, C means controller. That's what it's called, model, view, controller architecture. It's mainly used for to help separate the user from the other parts of the system. You can model your own system, you can view the system as an end user, then you can control as an observer. The observable design pattern is normally used to separate the model from the view. So you can observe as a third person, and you can view the model, and you can control the model. Say for example, if some problem or some scenario happens, if you become part of that issue, you cannot able to solve the issue. Just you come out or separate yourself from the issue, and you view the problem as a third party or as an observer. You can understand the scenario and you can control the scenario. Say the model is the diagram is clearly given, view by actor, and you will get the view of your complete architecture. Then you can control your architecture, receivers, actors, events. So you can control, add the events, control the events, start the event, stop the event, create and update the event. Then you can model. So if you want to change something, you want to add something, you want to delete something, you can do it. So you can modify and remodel and notify about the changes. So once the modifications are done, you can notify the changes that will be updated in the view. So that is called model, view, controller, architectural pattern. Model, view, and controller architectural pattern. So this pattern can be used depending upon the context. You can attain 6 benefits. So it supports data capture, increases cohesion, reduces coupling, increasing reuse, design for flexibility, design for testability. So these are the benefits. You can attain that. If you want to attain some more out of 10, you need to modify accordingly. So any doubts so far? So far we discussed all those things. In the previous class itself, I think 26th February, we had a class. During that time, we discussed process of design, principles leading to good design, techniques for making good design decisions, and good design document. These concepts we already discussed on, I think, 26th February, Saturday. We revised all those topics today. Today we discussed good design document concepts, 10 design principles, then design patterns. In under design patterns, we discussed 11 design patterns. Then we discussed our software architectural models, as well as within the architecture, we discussed 6 architectural patterns like a client and server, transaction processing, singleton, MVC architectural model, pipe and filter architectural model. So already I shared with you for the module unit 5, part 1 as well as part 2. You please go through the content. If you have any doubt, you can message me. You can send you message me through WhatsApp or to my personal WhatsApp number, or you can email me also. Already in the last class video recordings also I downloaded. I will share it with you, and today's class also I'll share it with you. So if you have any doubt in today's topic or in the previous classes, part 1 as well as part 2, you can raise the question anytime, and I will try to share with you some important the kind of questions that can be asked from this particular module. What kind of questions, what kind of examples, some important topics where they will ask you the questions with respect to this particular module alone. So any doubts so far?
No, ma'am.
No, ma'am.
No, ma'am.
Okay. So I think you have another class at 12:30, yeah?
Yes, ma'am.
Next
Yes,
class
ma'am.
you have 12:30. Yeah. So you will have any doubts, you can raise me the question at any time through my WhatsApp number or to my personal WhatsApp number or to my email ID. The video recordings Zoom class recordings of today's class and the previous class. I will try to upload and share it with you within today or tomorrow. Okay. Shall we end the class?
Yes, ma'am.
Yes, ma'am.
Yeah. So totally 8, 7. And with respect to the topic, research flow, how to fix the title, how to fix the objectives, any templates, any diagrammatic representation, or which kind of methodology I can use, how I can justify the results, what are the different design spaces available, how to rewrite or any template formatting. So if you have any doubt with respect to the publishing paper, domain various various journals available, especially SCI, SCIE based journals, which are relevant to your topic domain, or anything, any aspects of your research work, you can message me or you can email me. I will try to do my level best. All the very best.
Okay, ma'am.
Thank you,
Shall
ma'am.
we end?
Thank you, ma'am.
Yeah. Shall we end the class today?
Thank you, ma'am.
Thank you all. Shall I end the class?
Yes, ma'am.
Yes,
Ma'am,
ma'am.
yes, ma'am.
Thank you all.